Welcome. So on the agenda for today is notes on tangent, sine, and cosine, some practice problems embedded in here, and then a Google form. By the end of class today, you should be able to find the missing angles or side lengths of a right triangle based off of tangent, sine, and cosine. So when I'm referring to sine, tangent, and cosine, what I'm going to be using is this image here, and I'm picking to make angle A my reference angle. So this is really important because it depends on how you're going to label your side. So since I'm using this as my reference angle, A is going to be my opposite side, B is going to be my adjacent side, and C is going to be my hypotenuse. So when I'm referring to sine, it's the relationship between the opposite side over your hypotenuse. So in this case, A over C. When I'm referring to cosine, this is the relationship between your adjacent side over your hypotenuse. So in this case, B over C. And then tangent, we've been talking about, is the relationship between the opposite side over the adjacent side, or in this case, A over B. Remember, I'm using this as my reference angle. Your letters would be different in your labeling if you had chosen B as your reference angle. So in order to remember this, we use this mnemonic device, SOHCAHTOA. So sine, opposite of our hypotenuse, cosine, adjacent of our hypotenuse, and then tangent, opposite over adjacent. SOHCAHTOA. So let's go ahead and practice. For example, number 1, I want to find the sine of r. Again, keeping in mind, this is my theta, my reference angle r. I'm using SOHCAHTOA, and sine is opposite of our hypotenuse, 12 over 13. If I wanted to actually solve, I'd get 67.38. Cosine, ka, adjacent over hypotenuse, adjacent 5 over hypotenuse 13. And again, if I actually solved using inverse trig functions, I get 67.38. And then tangent, which again is 12 over 5, and I end up getting 67.38 degrees. This is just to show you that regardless of the trig function you use, if you know all your side lengths, you will end up getting the same result for your angle. So really quickly, special right triangles, just reminding you again how the 30, 60, 90 is a 1 to 2 to square root 3 ratio, and then the 45, 45, 90 is a 1 to 1 to square root 2 ratio. So if I wanted to find the sine of 60 degrees, again, SOHCAHTOA, opposite over hypotenuse, opposite to 60 degrees is square root 3, hypotenuse is 2. For cosine of 45, doesn't matter which angle I choose as a reference because both of my legs are the same amount. So I'll just say that this is my reference angle. So cosine is adjacent over hypotenuse, 1 over square root 2. But then I went ahead and I rationalized my denominator. So square root 2 over 2. Here I want to solve for u and for t. So first things first, if this is my reference angle, I'm going to go ahead and label my sides. And this is my adjacent side, my opposite side, and my hypotenuse. Keeping in mind SOHCAHTOA, if I'm solving for u, I want to know my adjacent, I know my hypotenuse, so I should be using cosine. If I want to solve for t, I want to know my opposite, I want to know my opposite, and I know my hypotenuse. So that means I should be using sine. And if I go ahead and I do that, I end up getting 3.4 as my u and 7.3 as my t. Same thing over here for my value of AB. AB, that is going to be my adjacent side to my reference angle. 6.1 is my O. And then I have my hypotenuse. Because I want to know my adjacent side and I know the opposite side, in this case, that means I should be using from SOHCAHTOA tangent. So the tangent of 41 degrees is 6.1 over AB. And in this case, when we solve, we end up getting 7.0 inches. And then these last two, again, keeping in mind SOHCAHTOA, labeling my side lengths, this is my reference angle, A, O, hypotenuse. I want to solve for MP, which is my O. I know my H from SOHCAHTOA, O and H is sine. So I'm going to get 3.1. Over here, if I label my side lengths, this is my adjacent, my opposite, the right angle points to my hypotenuse. I know my adjacent. I want to know PR, which is my hypotenuse. A and H is cosine, which is 11.4. And there you have it. That is your lesson on sine, cosine, and tangent.